Hello everybody, it's Crazy Logics 007 on YouTube, Crazy Logics on the forum, and everybody else just calls me Damon. This will be part 2 of the big PPI power class repair, and will probably be maybe 4 videos, but don't quote me on that. So here we go, and we'll get right into repair. Hey, that's kind of neat. Okay, so we have, if I shine some light in here, we have a via right there that is gone. It doesn't connect anywhere on the bottom of the board, but this little trace right here that's kind of ripped up is there, and it goes from here underneath the board to this point, and this point goes back to the pulse width modulation chip. I'm going to drill out that via hole and install a new eyelet. And when I do that, I'm going to wrap it with a little bit of magnet wire and then press it in and catch this little trace under the lip of that new eyelet, and that way when I solder it all together, there'll be extra wire to reinforce that trace and get that all in there with that eyelet and stuff, and I'll have a good place to solder to, and it'll be nice and well repaired. And I'll clean this up around here a little bit where the heat, whenever this was all damaged. I've still got to replace this resistor, and I've still got to order some FETs. I didn't realize I was out of power supply FETs, so I have to do a little ordering there. But through the magic of YouTube, you'll be able to see that. And like I said, once I get that fixed, we can solder in some new transistors, and I'll try to talk about that. If I don't get it in the video, I'm terribly sorry. I'll get it in a live stream, and maybe with a little smaller and simpler amp. Maybe that's best. Okay, I don't know if you can see that, but clamped it with my little point clamp that I made, and that took that little bitty eyelet and flared it out and smashed it onto the board. And I actually broke my little wire that I was going to use for some stability, but I've got that other little trace kind of under there. I don't know if I really need this now or not. I'll see if I can get it wrapped around there, and then I'm going to put a little flux, solder that, and then I'm going to brush on a tiny bit of green conformal board coating, solder mask, and then cure it with some black light. So we'll probably go back to the music while I do this, because I'm going to not be in the talky mood because it's all tiny. Okay, we have that repaired. What we need is to replace a few of these resistors. These resistors all ohmed out fine here, but I got 3 of them that are so discolored, meaning they've definitely taken some heat. They just the soot didn't wipe off. These ones on the outside are fine, I think, but I'm going to go ahead and out of caution change those. And then we got the other little resistor right over here, the 10 ohm resistor that needs to be replaced, and that should get us good there. So I'm going to do that work, and then we also need to know why this power supply died. And we haven't got to the output section yet, but since we're going to be rebuilding that and replacing these transistors, and they were a 2 SC3198 and the 2 SA1266, and I'm going to be replacing them with the 3904 and the 3906 to drive the power supply. So we'll fix up those resistors, put the transistors in, and then we'll check the drive real well on this, and then we'll be ready for 6 new FETs on each side. And we're going to put 3205s. These are 47 ohm gate resistors, so that worked out, even though it originally had IRF Z44s in it. But we've got 2 channels, and we need to check. Get my bald head out here. We're looking for diode on transistors. So these TIP 35s right here have shorted, so that's probably what caused the power supply to blow. So a couple things. I mentioned that if you set this back down the heat sink, there's no clamps because the bottom cover is the clamp, so you can make up some clamps. There's one other thing you can do while testing, and we're going to have to remove these 3 transistors, and I'll check each one of them after that. We may have only blown one, but they got to be replaced in a matching pair, and I may replace these 2 most likely, so that they're all matched up, because if I put modern 35s, I need to go ahead and put modern 36s in. But these little jumpers, you may have seen them on circuit boards sometimes to set settings. They used to be on the back of hard drives back in the day, these little jumpers like this. Well, on these boards, if I can keep my stuff all good, you'll see that pair of jumper pins right there. And there's one on each side, and those are the bias jump out things. So the bias on these boards, you can jump them with these little jumper pins, and it will defeat the BIOS, or the bias. Thinking of these little computer parts. These are in computers too, for jumpers to reset BIOS. Stuff like that. See how I'm getting confused? But I'm going to go ahead and put one on each one of those to take that out, so that once we do get the power supply built or rebuilt, and once I've taken these out, when I first power it up, these should not heat up because there is no bias setting, and we can at least check for voltages and stuff like that without having to worry about it overheat. And we can technically play through this one side. We might try that, and then we'll put in new FETs, or new transistors. Sorry, these are transistors, TIP 35s over here and 36s here, but we also need to check. These are the drivers for them and stuff like that, and make sure everything's okay. I still need to check these for shorts, so let's just go ahead and do that now. And both those show shorted. That's where our shorted bank is. When we pull that, it may go away. But these may have got damaged, so we may need to replace this drive side over here. And if so, we'll do that. Okay, I'm going to fire up my desoldering gun. We're going to pull these 3, that bad resistor, and these 3 resistors in the middle here, and then we'll test these 3. My wife calls this my fart gun. It's a desoldering gun. She says I ought to have a whole bunch of 8th grade boys just giggling at all my videos when I use this thing. So if you're going to laugh at the fart gun, just know that I'm laughing with you. should be able to. Oh, got that. Just come in here now and lift them right out. Like I said, the fart gun is awesome. And yep, I'm going to have to call it the fart gun. If my wife is willing to call it the fart gun, you know, then surely I got to be. Oh, put down in there. Alright. Got those out. We need a 100 ohm resistor. Now this is a precision resistor that I've got here. But this is brown, black, black. So it's starting from this side here. It's brown, black, black. And then it's got 2 additional bands because this is a 1% resistor. 4 band. I believe it's 1%. And that 100, reshape that a little, goes there. For some reason it's not wanting to go all the way through. There we go. Oh, I need a little pair of pliers or something. My fingers are not good at grabbing this. Alright, that looks good. And we need some 47 ohm resistors. And they're going to be, and these are, I buy everything basically 1%, so they all end up 5 band. But they are going to be yellow, purple, black. And my puppy dog needs to go potty. So give me a minute, guys. 1 second break to take the dog out. And we're back. So the dog, my wife will probably let the dog back in when she's done with her business. She likes to hang out here in the garage with me. Don't ask me why. Crazy mutt. It's because she thinks she's a puppy. And she thinks she has to be. If she could crawl in my lap, she would. But she's a little bit big for that. So this is going to be interesting. I have got to fit that resistor in that hole. Holy canooter valves. This, while all being underneath there. I really don't want to cut this leg a whole lot, but may have to. See if I can get that wiggled down in. Okay, we are going to trim that off a little, make that a little bit easier, and then just bend it around into a nice little curve so that we can get that in the hole. There we go. Got one end, bend the other side in and see if we can't get it to go. Oh, I'll tell you what's making this hard. My old man specs. If everything wasn't going in and out of focus, it'd be a little easier. Alright. If I get a hold of that. Start working that in. I'll trim these next ones. I always like leaving them long. It just makes it to where it's easier to tug on and make it position nice and neat. I like it to be nice and neat. There we go. Nice and neat in there, but we are going to trim these other two to make life a bit easier. All right. Oh, I bumped you. Yeah, this camera setup, trying to get a better view for you guys, is just got it right in my way. That's alright, I am working on getting a better camera setup. I promise. I know I keep saying that. Hey, alright. There's the puppy dog, and we got the resistor in. You guys will be real disappointed because there'll still be several. I got lots of footage of other stuff and other repairs that I've got to get edited and out there, so it will seem like a long time, and there will be videos mixed in that have much better quality, I'm sure. I'm right in your guys' way. See, I told you this is a terrible setup, trying to get this. But, and it's going to end up being better quality videos intermixed with the same old crap videos. And that's going to probably drive a few people nuts, because they're going to be like, wow, why does it get so terrible sometimes? And why can we not see as much? Do all this stuff. The one thing I really need after this is the microscope, so we can do close-up stuff. And I'm going to try to fiddle fart with my little bit cheapo microscope setup, because I really need it ASAP, but I can't afford to buy one of the big fancy ones. They're like $700. This resistor's being a bear. You guys can't even see any of that. But it's in between not only this, trying to get underneath this, but it's in between two other power jumpers. So you can only do it with tweezers, basically, to try to get in the hole. Did I get through? Can't see it. That got it through, I'm pretty sure. Yes. Good little tug. that little tug, pin my wires. Alright, get everything out of the way here. Let's get this soldered up before we attempt the transistors. That way we've got this trimmed up. So that's a view of it, and maybe we can get a good view there. My soldering iron to go here. For some reason it's not wanting to go. Just swap tips just in case. Well, that ain't good. Soldering iron. Oh, there we go. Aha. We've got a wire going bad. I kind of suspected that might happen. Because of the way they had put this together. Alright. We're going to see if we can get through this, and then I'm going to have to take a break and fix my soldering iron. And it keeps erroring on me. Have to take a break and fix it. But I'll fire up my other one. That's part of the reason why I got a second one. I knew this. It's the end right here. You can actually, oh, you can't see it. It's the end right here. You can actually see that blue wire and stuff. They didn't strain relief it very well. You know, it's cheap China stuff kind of, but it's actually a really good soldering iron. It's just you have to contend with fixing up a couple things yourself. The build quality is not there. Okay. That's why if you're going to do this a lot, you got to have a backup. IPA, isopropyl alcohol. Clean that up real nice. This other side needed a little wiping down too. And a paper towel. Dab it up. Dabbing it with a paper towel helps suck up the dirt and debris that you've kind of done there. And then I just go over all of it with a Q-tip just barely dipped in the IPA. And you can see it just gets crazy dirty from flux and other stuff that you're cleaning off. This bottom side's not been cleaned up near as much as the top side had. I scrubbed more over here on where these transistors had burnt for the drive circuit than I did anything. Alright. Okay, we got the resistors replaced. We're ready to put the drive transistors in, but I got to fix my soldering iron because I like that other soldering iron better. But what we're going to do here is here's those 3 transistors that were bad. Let's get the meter in here real quick. Remember how I said probably just one of them was dead? That's the one that's dead. So the other thing we were going to check, let's pull our meter back in here. And our short did go away on the drive, but we're going to look at that drive real careful because a lot of times these get damaged when that side blows. Now the fact that it popped one FET, I don't know. Like I said, I'll be real careful. I'm not real happy about not replacing that drive. I probably will, especially if I got the parts already laying around. And excuse me. You know, it takes just one to short the output to cause too much of a current load. And then we had power supply FETs popping. It didn't blow this side on the power supply, but it did blow this side, which then should have popped the fuse that they had installed. So, you know, we may have limited the damage on this amp, especially if they had the correct fuse on it. Then that would have, you know, when that popped and it causes this to overcurrent, and one of these popped, or a couple of these popped, and then the fuse pops real quick, you know, then you still have a good working side. Half the dang power supply was still working. So that kind of stuff, you know. Fuses are important. Okay, so I got to fix my soldering iron. And then we're going to put transistors in, and I need to go ahead and pull those. Fire up the toot machine, the fart gun. We can go ahead. Are those the same across? That's the 36s. That's the 36s. Okay. So they are identical across. Be right back when my soldering iron's fixed.